Okay, so today we're going to talk about triangle inequalities. We have two goals for today. Goal number one is I can list angle measures based on knowledge of their side lengths. And then goal number two is vice versa of that. If I gave you side lengths, can you tell me about their angle measures? Okay, so first a little warm up here. I want to find an example of each. Okay, so we're going to find a median, an altitude, an angle bisector, and a perpendicular bisector. So one thing that you have to remember is that these are special segments in triangles. So all of your answers should be segments, or technically they could be lines. Okay, let's look at the first one here. It's a median. So remember what a median gives us? It gives us two congruent segments, and it comes from a vertex. So I could start in each corner and say, all right, I'm going to come from this vertex at the opposite side. Do I get two congruent segments? No, it's not marked that way. I could do it that way, or I can just look for the segment that does that. So if you look, comes from a vertex, hits the opposite side, gives me two congruent segments. So that is my median. So my median is BD, or DB is fine also. Next, let's look for an angle bisector. An angle bisector gives you two congruent angles. So if you look, here's my two congruent angles. What's doing that? That's this piece right here, that segment, which is segment AG or GA. Next is an altitude. My altitude comes from a vertex, hits the opposite side, and gives me right angles. So it can't be this because that's not coming from a vertex. Remember, you're looking for something that comes from a vertex. This comes from the vertex, hits the opposite side, and gives me right angles. So that is my altitude CE. And then last but not least, my perpendicular bisector. I highlighted it moments ago. It does not have to come from a vertex, but it has to give me two congruent pieces and right angles. So that is my perpendicular bisector, which is BF or FB. Notice I put segment bars above all of my answers because these are special segments in triangles. You could have also called this line BF because that, if you extended it farther, is a line. Okay, so before we start here, we have to make sure you know what it means to be opposite of or across from, which are synonymous terms. So it says, which side is across from angle C? Okay, so first off, here's angle C. The side across from it, or the side opposite of it, is side AB, or BA. Next one says, which side is across from angle A? So here's angle A. If I go opposite of it, that's this side right here, which is BC. Another way of doing this if you're having issues is that you could say, if I want to know what's opposite of angle C, I can cover up angle C because that's not, angle C can't, anything with C can't be opposite of it. So if you look, the only thing that's left is side AB. If I want to know what's opposite of angle A, I can cover up angle A, and you can see that BC is the only thing left. So that helps too, some people. All right, last one. Which angle is across from AC? So here's AC. I want to know which angle is opposite of it, and that's angle B. Same trick works here, is that you could cover up AC and say, oh, B is opposite of it, or across. So once again, when I say opposite of or across from, same thing. Okay, so here's what the relationships are. Angle side relationship in triangles. The biggest side of a triangle is opposite the biggest angle. Okay, so the biggest side's opposite of the biggest angle. The smallest side's opposite of the smallest angle. So if I gave you this example, and I said, what's the biggest side between those two? You're not even worried about side AB. You're just looking at AC and BC. What's the biggest side? You're going to say the side that's 14 is bigger, right? So if you notice right here, it says 14 is greater than BC. So AC is greater than BC. So if that's true, which angle is bigger? And that's the angle that's opposite of this. So angle B is greater than the angle opposite of this, which is angle A. All right, same thing goes if I gave you angles. So here, what I could really do is ask you, what's the biggest side? But instead, I'm going to say, okay, this angle's 40 degrees. This angle's 30 degrees. So angle A is greater than angle C. Okay, now, if I want to compare that red and blue side, which one's longer? So this one's opposite of my 40-degree angle, so BC is greater than, opposite of this is AB. Now, if I wanted to find this angle right here, remember I could do that using the triangle sum theorem. I could do 40 plus 30 is 70. 180 minus that is 110 degrees. So if you really want to know the biggest side, that's the one across from B, which is side AC. Okay, so let's do a couple problems here that are super basic. Most people find these rather easy. So it says, write the angles of each triangle in order from smallest to largest. So first off, please don't give me the sides. The sides are labeled. I wouldn't ask you which is the biggest side. It's clearly this one. Okay, so I'm asking you the angles. So realize you're giving me a list. So I'm going to go a list, 3 things. And they're all angles. So I'm going to put angle in front of it so I don't forget it. Okay, so also I want to know smallest to largest. So to do this, I'm going to find my smallest side because I want my smallest angle first. So my smallest side is this side right here, which is 17.2. So my angle opposite of it is my smallest angle. So angle F is my smallest angle. Then I'm going to find my next biggest side. My next biggest side is this side right here, which is 19.6. The angle opposite of that is the next biggest, which is angle H. And then finally angle G, which is the only one left. But if you look, this is 20.4. Opposite of that is angle G. Okay, go ahead and pause the video and try the next one on your own. All right, remember we want angles smallest to largest. So the smallest side is 9. The angle opposite of that is angle B. Next is this one that's 15. The angle opposite of that is angle A. And then my biggest side is AB, so my angle opposite of that is angle C. So there's my list of angles in order from smallest to biggest, smallest to largest. Okay, now we're going to write the sides of each triangle from longest to shortest. So these are sides, and I want longest to shortest. So once again, I'm doing a list. So 1, 2, 3 things, but this time there's sides. So I'm going to put segment bars so I don't forget those. Okay, so I need my longest side, which is across from my biggest angle. So I need all 3 angles to do this, and I only have 2 right now. So I'm going to find the third angle by doing 72 plus 60. That is 2, that's 13, that's 132, and then I have to do 180 minus that. Don't forget to subtract that from 180, so that is 48 degrees. Okay, so now I'm able to do what they asked me for. I got to look again because I forgot I want the longest to shortest side. So I need my biggest angle. My biggest angle is 72, so my biggest side is PR or RP. And make sure you have your segment bar above it. All right, my next biggest side is this 60-degree angle. So my next biggest angle is a 60-degree angle, so my next biggest side is QR or RQ. And then finally, my smallest angle is 48, so my biggest side is QP or PQ. Okay, go ahead and pause the video and try this last one here on your own. All right, so this is 90 degrees, and then this would be 68 degrees. Okay, so I want longest to shortest, so my biggest angle is 90, so my biggest side is DE or ED. Don't forget the segment bar above it. My next biggest angle is 68, so my next biggest side is this side, which is DF or FD. And then my smallest angle is 22, so my smallest side is EF or FE. Okay? Okay, so here's a little puzzle. It says list the sides of each triangle in order from longest to shortest. The whole goal is to get to this question right here. Okay? So make sure you pay attention to this because it does trick some people up. So this first part shouldn't. I want the in triangle PQS, I want the sides from longest to shortest. So here's PQS. So I'm just going to do this triangle. I'm going to pay no attention to the other triangle right now. I'm actually even going to move it over there. I'm going to find the missing angle. So I'm going to do 57 plus 63, 180 minus that, and that's 60 degrees. Okay, and then I want longest to shortest. So here's 63, the side opposite's the longest, so that's PQ. Then 60 comes next, the side opposite of that is PS or SP. And then my smallest side is opposite of this 57-degree angle, and that is QS. Okay, so now I am going to do that next with triangle RSQ. So now I'm going to look at triangle RSQ, which is this triangle right here. All right, same thing. I'm going to fill in my missing angle. I'm going to do 70 plus 56, which is 126. 180 minus 126, which is 54 degrees. Okay, so now once again I want longest to shortest. So my biggest side in this triangle is opposite of the 70-degree angle. So my biggest side in that triangle is QS. Then 56 is the next biggest angle, so QR. And then finally my smallest side in that triangle is RS. Okay, so the whole point of this is to answer this question. What's the longest side in the entire figure? So I'll show you what people do wrong. They'll look at this, they'll have all these filled in, they'll go, oh, here's 70. The answer is QS. Okay, but if you look back at my list right here, this was the longest, this was the shortest, this was the longest, this was the shortest. So if I say QS is the longest side in the whole entire figure, it's the shortest side right here. How could it possibly be the longest side? So PQ is the longest side. Okay, PQ is the longest side. So here's what you want to do.
I'm having trouble hearing you.
Oops, that's Siri. Here's what you want to do. We're going to do an example like that, and we're not going to make this list right here. You always can, but we're going to look away how to not make that list. Here's how I do it. I'll do a quick explanation. What I do is I say, okay, I want to find the longest side. What's the biggest side that I think so far? I'm going to find my biggest angle, which is 70. I'm going to go opposite of that. I'm going to say, okay, I think the answer is QS. But now I have to check in both triangles to see if QS is the biggest. If it's not, then the other one takes over. So in this blue triangle, is QS the biggest side? Yes, check. So far, so good. Now look at the triangle in red. Is QS the biggest side? No, PQ is. So it takes over, and PQ is my biggest side. All right, let's try one, see if we can do it. First, I'm going to fill in my missing angles. So I'm going to do 55 plus 51, which is 106. 180 minus 106 is 74 degrees. Next one, 56 plus 57 is 113. 180 minus 113 is 67. Let's see, 14. Yes, that sounds right. Okay. So now, if you look, it says, what's the longest side in the entire figure? What's the longest side? I could have asked for shortest, but I asked for longest. So what I'm going to do is I'm going to find the biggest angle. The biggest angle is 74. What's the side opposite of that? QS. So I'm going to say, okay, I think the answer is QS. So now I'm going to check both triangles to see if QS is the biggest side. So I'll start with the triangle on the left. Is QS the biggest side there? Yes, so far so good. Now I'm going to check QS in the triangle on the right. Is QS the biggest side in this triangle? Let's see. No, it's not. This side's the longest. RS. So RS takes over. RS is the biggest. Okay. All right, the next thing we have to talk about is that if I give you three numbers and I say there are three sides of a triangle, not necessarily always true. A triangle is formed by three segments, but not every set of three segments can form a triangle. So if I have a triangle that looks like this first triangle right here, this bottom part's 7, and this is 4, and this is 4, that will form a triangle. But if I have a triangle where this bottom part is 7 and these sides are only 3 and 3, they're not going to touch. So could we make a hypothesis of when we think that those two will touch? So if you look at what you see here, these two, 4 and 4, they make 8. 8 is greater than 7. If you look at these two, that's 3 and 3, which makes 6. 6 is not greater than 7. 6 is less than 7. So this is not going to form a triangle. So to sum this up here, the two smaller or shorter sides of a triangle must add up to be greater than the longest side. So the two shortest side must add up to be greater than the longest side. All right, so let's try example 5 together. It says, tell whether the triangle can have sides with the given lengths. Show your work. So if you just put yes or no, you're not going to get any credit. So what I'm going to do is I'm going to take the two shortest side. I'm going to add them and see if it's greater than 19. So I have 17 is greater than 19. Is 17 greater than 19? No. So no, this is not a triangle. All right, we have 2 more here. Try those on your own. All right, the two shortest sides, 2 plus 3 plus 3.1 is greater than 4.6. So that's 5.4 is greater than 4.6. Is 5.4 greater than 4.6? Yes, this is a triangle. All right, let's try this one. 2 smaller sides, 8 plus 13 has to be greater than 21. 21 is greater than 21. Is 21 greater than 21? If I have $21 and you have $21, do I have more money than you? No, that's not true. So this will not form a triangle. Okay? All right, the last problem here. It says list the sides of triangle ABC from longest to shortest, and then it gives us information. So what's the first thing you think we have to do here? The answer is draw a picture. So we're going to draw a triangle. It doesn't say if it's isosceles or equilateral or it doesn't give me any information. So I'm going to make something that looks scalene because I don't know what it looks like. Then I'm going to label the angles A, B, and C. Now I'm going to label what they give me. They give me angle A is 5x plus 2. When you're labeling an angle, make sure you're doing it on the inside of your triangle. Angle B is 6x minus 10. And angle C is x plus 20. All right, so first thing I have to do is I have to find a way to solve for x. So if you notice, you have this angle, and this angle. You have all 3 angles. So if we have all 3 angles, we can always find out what they are. So we're going to add them up. 5x plus 2 plus 6x minus 10 plus x plus 20 equals 180. And then we're going to combine like terms. So I have 5x, 6x, and x, which is 12x. I have positive 2, negative 10, and positive 20, which is 12, equals 180. I'm going to subtract 12 from both sides. I have 12x is equal to 168, and now I'm going to divide by 12. So I have x is 14. Did it ask me for x? No, so I'm going to unbox that. Okay, so now I know x is 14. Now that I know x is 14, what can I do? I can plug it into each of my angles, so I'm going to do that next. I'm going to do 5 times 14 plus 2. That is 72 degrees. So I can cross that off and put 72 degrees for angle A. Next, I have 6 times 14 minus 10. So that's 60 plus 24 is 84 minus 10. This is 74 degrees. And cross that off and put 74 degrees. Next, I have 14 plus 20, 34 degrees. Oops, that looks like 340. 34 degrees. Okay, so now let me see what they asked me for. Did they ask me to list my angles? No. They asked me to list my sides. Okay, so I'm going to find my sides from longest to shortest. So in order to find my biggest side, I need my biggest angle first. My biggest angle is 74 degrees. So if that's my biggest angle, the side opposite of it is my biggest side. So my biggest side is side AC. Next, I want my next biggest angle. That's this one, that's 72. The side opposite of that is BC. So my next biggest side is BC. And last but not least, my smallest side is the only one left over, and that's opposite of my 34-degree angle, which is side AB or BA. All right, that's it for triangle inequalities. You can go ahead and re-rate yourself. How do you feel about listing angle measures based on side lengths? So can you do side lengths from smallest to biggest because you know angles? And then vice versa for this.